Thank you very much. I hope I'll deserve that. So, last couple of years, kind of were a bit weird for everybody, I guess. And I used to do a lot of traveling. There wasn't much travel last few years, so I decided I'm just going to program and program and program. And I built a new thing, and I'm really proud of that. But kind of, as I was building that, it kind of started taking off and then started dying off and started taking off and dying off. It's a roller coaster. And somewhere around last year this time, when I was speaking at ATVIE22 last year, I was really depressed about the whole thing and I was planning to shut it down. Because what had happened is kind of the usage had gone down significantly. So this is 2021. It was going up, going up, going up. This is kind of the Google Search Console showing how many people were coming from Google to my website, my product website. And then you can see somewhere in May something happened. And all of a sudden I lost about half the traffic per day. And then it went, oh, this is per week. And then it went worse and worse and worse. And it got really bad where at some point I was really thinking about killing the whole thing. And at this point, I've realized that most of the kind of content on the internet is not written for humans anymore. Content got weaponized. The content is written for some silly algorithm at Google, and it makes no sense at all. It's just kind of people bombard stuff and they build it. And if you're not weaponizing your content, if you're just trying to be kind of good for your users and build stuff, you should be building, somebody else weaponizes the content and takes your traffic. So kind of somewhere over here, a competitor basically started stealing all my traffic, and I didn't realize that until it was very late. So today, we have this crazy algorithm at Google that kind of people are writing content for. We have tools, because this is weaponized, that companies can use, like my competitors were using at this point, to figure out what kind of content to write for this algorithm. So we have now even GPT-3. Who's heard of GPT-3? Half of the room. Okay, so kind of we have this crazy algorithm that can generate text like humans can. And that can help people who are weaponizing content produce thousands of web pages in a minute that look sensible. So we have like algorithms producing content for algorithms, producing content for kind of scraping algorithms that then analyze and turn it back into the loop. And it's all gone crazy. Very soon humans will no longer be visiting the internet at all. It's going to be kind of, first of all, we're not going to understand the content. And the second thing is we're not going to be able to pay for the electricity to visit internet anymore. So there's some statistics I've read where in 2017 there was 2.7 zettabytes of data on the internet. I don't fucking know what a zettabyte is, but it's a lot. Now, in 2022, Statista estimated there's 64 zettabytes. So over the last 5 years, this whole weaponized content exploded from 2.7 to 64. And there's an estimate by IDC that in 2025 there's going to be almost 200 zettabytes of content online. It's insane. Now, I kind of, somewhere over here, started paying consultants to help me figure out what went wrong. And I had to go through 3 different companies. The first company sent me this PDF with 70 pages of shit I need to fix. Totally insane. And then kind of I paid somebody else and they got me to pay for some ads and that failed. The third company actually figured stuff out. And we were able to build up kind of content. This is, the last 8 months. And you can see it built from like 100 people coming per day to 10,000 yesterday. It passed 11,000. So it kind of became a small success. And I'm very proud of that. And a lot of it had to do with me learning absolutely more than I should about how to do content for Google's algorithms. But if you look at kind of the usage of this, and this is another quite insane thing, this is the graph that is the key use case. How many times do people trigger the key use case on the system? How much is the system being used? Somewhere in November, it was 150 times per day last year. And kind of in August this year, it was 36,000 per day. So like I've never, ever, ever been involved in something that grows this quickly. It's totally insane. You start hitting edge cases that are flukes that should never, ever happen once or twice a week. And you start dealing with that stuff. For example, last week twice, I had 2 different people uploading a file name where Unicode codes were flipped around, and it was invalid Unicode. I had no idea that's possible. The second big question is, how on earth do you rename a file so it has invalid Unicode in? But it doesn't matter, at this point the system has to start dealing with these things once or twice a week. So there's a ton of stuff that happens there that I had to learn about. It's partially what I want to talk about. How do we manage this learning as part of software development? The other thing that kind of starts happening when you start hitting this scale is tools become necessary. Automation becomes necessary. Something needs to troll through this stuff and figure out signal from the noise. There's a million things that can go wrong. Sometimes things go wrong because people installed a stupid Chrome extension. Sometimes things go wrong because I have something wrong on the website. So I actually, gave up and installed one of these tools that weaponizes content somewhere over here to start analyzing my site and figure out what was there. And those tools will do lots of interesting things. They will spot some stupid bugs. For example, I had a Greek language page where I used GR instead of EL as the language code. And it said, oh, you have a wrong language code. Then it reports a bunch of other things, but it reported about 500 errors for miscoded alternative pages. So what happens, kind of Google's algorithm is realized that this is an arms race. You have kind of Google indexing, then tools analyzing Google, then Google trying to prevent people from cheating, and this is just an arms race. And a big part of this is kind of creating duplicated content. As the easiest way to create 1,000 pages is to create one and just tweak it a bit. And Google fights against that and starts detecting duplicated pages. But if there's some genuine content that is kind of looks very similar but is not actually duplicate, it's for a different purpose, you can tell Google, hey, this is intentional, please don't delist my pages. And the way you do that is you put these tags, especially if they're language alternatives. So kind of, this is an example where you say the canonical page is this, but then I have like a German version and an English version. And they will have similar content. They will have similar images, similar structure. They're not duplicates. Please do not delist them. And you can kind of give Google advice like this. Now, this tool I installed all of a sudden reports 500 errors with stuff like this. And it says, oh, all this stuff is mislabeled. You're not doing it right. You should be doing it this way. You're doing it that way. I start panicking because, this is maybe something we should fix. And in this case, it started identifying pairs of language pages that are kind of marked for Google. So I have a page in English and a page in German, kind of slightly different things because people search for different things in German and in English. Again, this content is not written for people, but for the machine. But kind of now this thing is warning me. And I'm now kind of faced with a problem. Like, this tool is telling me to fix it. The documentation I read on Google disagrees. Some blog posts people posted say, what I've done is horrible and I need to fix it immediately. There was a blog post that says, this is the one thing you cannot get wrong if you're doing international pages. At the same time, my international pages are getting a lot of traffic. So did I do it wrong? Did I not do it wrong? I don't know. So I called up the people that I paid in October and November last year, and I asked them what they think about this. Should I change this? Should I not change this? And I got like a response that really made me angry. They said, well, in theory, you should change it. And I realized, this is what I do to people as a consultant. I go there, I listen to them, and say, well, it depends. And I was like, tell me what to do. So should I change this or should I not change this? I paid you money, tell me. How do I solve this stuff? And whenever people tell me something like this, I remember there's kind of a famous quote that's attributed to Albert Einstein, it's attributed to C. Erhard, it's attributed to a bunch of people, but I actually nailed it down to kind of a guy called Benjamin Brewster who published something in 1882. This is how much time I had free on my hands during Corona. I was researching this shit. So, and the quote goes kind of, in theory, there is no difference between theory and practice. But in practice, there is. So So in theory, we should fix this, yes. But should we or should we not? That depends on a bunch of factors. It depends on, what is the win if we fix it? Like, will I get more traffic from this? Will I get significantly more traffic? Will I not get more traffic? I don't know. What is the potential risk of this going wrong? What is the cost of doing that? I mean, these are some HTML tags, so okay, a couple of hours cost. But that's not the only way to measure cost. If I mess up my pages, I could lose all the traffic. I could, like, you know, lose 80% of the revenue. So yes, 20 minutes of work, 80% of the revenue. So, you know, not an easy thing. And at this point, it's really not nice to tell me in theory you should fix this. I want certainty. But unfortunately, certainty doesn't exist in today's world, especially online. And when we talk about theory, in theory and things like that, another wonderful, wonderful, wonderful thing that I think everybody should read is a paper written in 1985 by Peter Naur. If you've studied software development, you've probably heard of Naur-Beckus notation or Beckus-Naur notation or something like that. And Peter Naur of the Beckus-Naur notation wrote this wonderful paper where he said, and the link is here so you can download it from the slides. He said, like, programming must involve as the essential component building up of the programmer's knowledge. We start not knowing how to do something, then we kind of build up knowledge about that. And then he finishes the sentence by saying that the programmer's knowledge should be properly regarded as a theory. And this whole kind of system of theories there that he explains. So the paper is called Programming as Theory Building. And I think that really summarizes what we do when we model. There was a talk about collaborative modeling just in this room. We think about how the world works. We have a theory about that. We have a theory what the users are going to do. We have a theory of, you know, how the world is going to react to this or that. And then we build a system based on the theory. And Peter talks about how communicating this theory to the next programmer is the most important job a person can do. And that's why collaborative modeling, again, becomes so important, because it's passing on this. Anyway, so I like this concept of kind of evolving the theory as we develop stuff. And there was another really interesting case study about kind of theories and things like that from motorcycle racing. I think I talked about this last year, so I'm not going to kind of repeat the whole story again. But in 2003, Ducati, the motorcycle manufacturer, they started competing in a race that they have not competed before in. Totally new category. So they approached this thing as a learning exercise. They said, this first season, we're not going to try to win. We're not going to try to be even good. What we're going to figure out is, how do we even compete in this race? And they equipped the motorbike with 28 sensors. They built the bike so that different parts could be moved around easily and removed and replaced. And then they had a debrief after every race with the drivers. They were looking at the sensors. The drivers were talking about how the bike behaved. And somewhere halfway through the season, something really interesting started happening. They started winning. And at the end of they ended the season in the second place overall. There's a great Harvard Business Review article about that. Again, I'll give you the link in the slides. You can download them. And in the article, there is this wonderful quote I remembered where they say, learning is the process of updating our theories. So we have a theory about how the world works. We have a theory about what the users want. We have a theory about, you know, what we should do or not do. And then learning is the process how we update these theories. And what I'm trying to say is there's two different types of work we need to do when we're developing something. There's kind of this whole, I have no idea how it's going to work really, and I'm trying to figure it out. And then there's this whole, yes, we know how it's going to work, we're going to build it out, and we're going to profit from it. And we need to recognize these two different types of work and manage them in a different way. Because people have been trying to manage them in the same way for decades, and it just doesn't work. We need to appreciate that there are different types of work. So kind of, I'm going to call the stuff on this side learning stories, and I'm going to call the stuff on this side earning stories. I think kind of that's a metaphor, or not a metaphor, a naming convention I've stolen from Craig Larman. I don't know if it's originally his or he stole it from somewhere else. But I think we need to figure out really how do we manage these learning stories. We know how to do this stuff. But how do we update our theories effectively? And whenever I talk about this with people, there's a couple of typical complaints why this cannot be done. why we can't put learning stories in. So people talk about how, oh, you know, it's going to be too expensive. So we're going to spend too much time on this. It's going to delay working on the real features. Or it's going to be difficult to prioritize this. How do we put this in the backlog? How do we compare this to other things? How does a product owner decide should people learn or work on value? And you know, if you give business users a choice, should the developers learn or should they kind of make you something that earns money? Well, always earn money. That's not a problem at all. Priorities are easy. Then kind of, you know, it's impossible to do because we can't talk to the users, we can't access the users, we are 10 steps divorced from even talking to a real user, or it's going to be politically impossible to talk to them, or all sorts of excuses like this. So when people have excuses like this, then they claim that they have only one type of story in the backlog, and that's kind of the, you know, value story or something, but that's a lie. If we take these excuses and we don't do learning stories, we still have two types of stories. We have these kind of value stories, and then we have horror stories when something doesn't really work out. So let's avoid having horror stories. And even when people don't intend to learn, they learn through development because that's an essential part, as Naur says. And there's a couple of kind of things to think about. I like to think about this because I'm a consultant in quadrants. So there's kind of, are we focused on something in particular? Or are we just kind of trying to, are we learning about tangential stuff? So if I develop something and then I get a bug about somebody else uploading a Unicode file name with flipped Unicode characters, codes, I've learned that people can create invalid Unicode. That's not what I was planning to learn, but I've learned that. So that's tangential information. But if I'm doing something to really learn, you know, how Google acts and I learn about that, that's more focused. And we have another category here. Are we learning intentionally because we wanted to learn? Or are we learning because, hey, you know, some chance happened there? So there's a, you know, we can talk about kind of bugs really being here because that's what bugs are. Bugs are a way for us to update our theory. We are wrong, but it's totally kind of unfocused and by chance. Focused by chance is doing a product demo. We're showing something to a user and then people say, oh, this should be yellow, or oh, this should be, you know, it shouldn't work like that. This category here is what 10 years ago we used to do when we sit behind a user and observe a user doing something. We are intentionally really learning, but we're learning kind of lots of tangential stuff. And finally, kind of this category here is really what I want to talk about today, learning stories, where we intentionally want to learn something and we're really focused on that. Now, the first objection to this is always going to be it costs too much. And we need to manage that cost. It costs too much is a problem to be solved, not a conclusion. And for this problem, unfortunately, in this case, you know, the traditional Austrian solution would not work because I already am from Eastern Europe, so there's no way for me to send it somewhere cheaper. But the traditional Eastern Europe solution actually works. We're going to cheat. And we're going to cheat and cheat and cheat and cheat and cheat our way out of this. But we're going to cheat in a very specific way. So, you know, I can modify the website to generate all these things, and it's probably going to take a couple of hours and make sure that I'm not, you know, regressing into something and breaking something else, test the pipeline. Or after the website is built and deployed, I can download a pair of pages. I've done this with the Hungarian pages. I can download the HTML, tweak the HTML, and upload it again. I've not broken any code. I've not had to mess up my pipeline. I've not had to do anything else. And then I can measure kind of the outcome of that. I've cheated. And now the first complaint you're going to get when people say something like this is, oh, but that will never scale. You've modified 2 pages, but you know, how are you going to modify 500 pages? The trick is, we are talking about something very focused, so you never need to modify 500 pages. We need to modify enough pages to learn. So this is where the first rule of working with learning stories is something I've stolen from Paul Graham from Y Combinator. And is this first brilliant advice for startups is just do things that don't scale. Just don't worry about doing things that scale. We're trying to learn. We're not trying to build the most secure, the most brilliant solution. We're trying to do enough of this so we can learn what Google will do. And this is a brilliant way of reducing the cost of development. Figure out how to deploy this to a smaller group, to something that really doesn't, do stuff manually. Send some emails, upload some web pages, modify them by hand, expose it, build something that does not support 1 million users, supports 1,000 users, and then shut it down after 1,000 users talk to it. We don't need to scale this stuff. So the next problem we have is really how do we start managing this stuff? If we do stuff that doesn't scale, if we do stuff that's not up to the quality of the rest of the system, if it's not what everything should be, how do we capture this? How do we describe it? How do we manage this? And this is where people start really struggling. When I did a spec by example book, I was interviewing people about how they do things where there's a significant amount of analysis required, where people need to look at the legislation, or where there's no single true answer to anything. And I was consistently getting the response that, okay, they do it a few iterations ahead or one iteration ahead, and it's really, really difficult to kind of plug it as a user story, so they had to lie, and everybody felt dirty because they were lying, and things like that. And if you try to fit it into a user story template, it just doesn't fit. Like, how do I describe this? Like, as a developer, in order to, I have no idea even what. I want to know how Google internal decides stuff. Good luck with that, man. That's, the second biggest secret today. The first biggest secret is, of course, how we're going to pay for warming up this winter. But anyway, so as a dev, that doesn't work. But as a product owner, maybe, in order to know what to request, perhaps, I need to know if Google search engine has a bug. Like if the documentation, as they said, should be, if I break it like that, do they have a bug? Do we need to fix the bug? And now we have this really kind of potential way in, but still as a product owner sounds a bit dirty. It's not really a good way of doing that. So Larman and Bas Wode wrote about this kind of stuff in Practices for Scaling Lean and Agile, and they had a couple of proposals for this. One of the proposals for this is to try kind of genuine research as a product backlog increment. It doesn't really matter if it's a user story or not. Put a research task in. But make sure it's genuine research, like somebody needs to research this, study some documentation or something like that. And that's what most people were doing that was successful when I was interviewing for the spec by example book. The other thing he talks about is kind of plan this thing as a bounded research. Like, here's 3 days, here's 20 minutes, here's, we need to know this by this date because we need to start kind of deploying. And they said kind of really 3 big problems when people start doing this is all of a sudden you start seeing fake research items in the backlog. It's like, oh, we need to do UX design, but we can't say we need to do UX design. We're going to say we're going to do some research with users. And you're not researching anything. You're just kind of people drawing stuff in Photoshop. So then kind of passing regular analysis as research is also dangerous because then we hide the amount of analysis we need to do. There's kind of studying really unusual stuff, and there's, okay, we talk to business users and figure out what we need to do. So don't fake research. And he said that, the third thing that people tend to mess up with is they create special research teams. And then we have a problem of handing knowledge over. We have a problem of kind of somebody creating random work and doing some, they create a room where they have lazy bags and Post-its and brilliant stuff and never really produce anything of value. So let's not do that. And Larman says kind of there's a couple of things we should focus on when we do this. And the first thing is to really kind of make sure that this produces work useful for the product owner. So that's why I think, if you do need to describe it as, please don't as a user story, but the stakeholder there is the product owner, because it's helping product owners decide what to do next. And he said focus on tangible outputs, focus on some reports, focus on some data that the product owner can use to decide. Work back from the decision the product owner needs to make, figure out what data we need to provide. And he says research should lead really, really quickly, and this is ideal, to customer-centric product backlog increments. That's kind of what his idea is. Now, I think this really, really quickly is crucial here. Because if it takes too long, then it stops being valuable. And this is because earning stories and learning stories, they have a totally different value proposition. So for earning stories, the value proposition usually goes like this. So we deploy something, and then some users use it, and some more users use it, and at some point it becomes really valuable, hopefully, for lots of people and for us. And then at some point, all our competitors have the same thing, or the user preferences change, or people are no longer using this type of device, and then the value drops. But there's kind of the value accumulates mostly over time, and usually the value you get immediately after you deploy something is just an indicator. It's not really the value you'll get. So it compounds over time. For learning stories, the graph is totally different. For learning stories, it's more like this. It kind of kicks in like a morning espresso and disappears kind of very quickly. So we get a lot of value after we have done the learning story, because the product owner can hopefully decide what to do next. Should we fix this? Should we not fix this? After that, the value is gone. And we need, again, to manage and prioritize these things differently. And if you have a learning story there and it's sitting for 6 months in your backlog, it's pointless. It's probably expired already. There's, the other big thing that happens here is how do we then estimate these things? If we can't put it in a story format, if we can't explain what it's for, how do we give an estimate how long it's going to take? And one of the best suggestions I have there is don't even try to estimate it. The reason why people estimate things is that so we know how much work we can do next iteration or when something is going to be finished compared to other things. Another reason why people estimate is so they can kind of do capacity planning. They can know how much work they can fit into this iteration. And what's really important, kind of again here, speaking from the experience of interviewing people for the Spec by Example book, is they were all struggling trying to kind of make sure that they don't have too much research work in an iteration, that they get some value done, but also that the value work doesn't always take precedence over the research work. And I think a much better solution for all these problems is to just assign a budget. Assign a budget in terms of time. Assign a budget in terms of money. And that resolves all these problems. If we say, look, you're allowed to research this thing for the duration of 1 day, or 1 week, or 6 months, or whatever, then we don't have to estimate it. We can say, look, this is how much time you can spend on it. If you resolve it by then, that's brilliant. If you resolve it faster, even better. But if you don't resolve it by then, we're killing it. And this is where we need to figure out, well, how do we assign the right budget to this? What is the right budget? Is half a day enough? Is 20 minutes enough? Is 6 months enough? And this really depends on how valuable something is. If I'm doing some learning stories to decide where I'm going to invest 50 developers' time over the next 6 months, well, we're talking about millions of euros of value. Probably okay to spend a week, a month. If I'm doing something to okay, should we tweak this for 2 days or not? Well, maybe 20 minutes or something like that. Capers-Jones has a book on software engineering economics he published in the 80s. I really don't know how relevant the conclusions still are. It was a different world back then. But there's an interesting sentence there. He talks about how software development is inherently risky. And if you can't get at least a 10 times return on your investment, you should probably be working on something more valuable. So, using that as a guideline, if we can't kind of pack a learning story in 10% of what we need to do, well, probably not worth doing. Let's do something else. Let's find something more valuable and then do a learning story of that. Now, there's going to be a couple of kind of things here, and one of the things that we need to look at is how do we even assign a value to this? And this is why I love a book written by Douglas Hubbard. I've been recommending this book for 10 years now, almost every talk. It's called How to Measure Anything. And it's a book about business metrics, and there's a couple of really good statements in the book. One of the statements is about the value of a piece of information. And he talks about how the value of a piece of information is kind of proportional to the value of the decision it helps you inform. So this fits into, okay, it's 10% of the value of the kind of whole thing. It's 10% of the value of this. And also he says, without risk, information would have no value in decision making. If there's no risk, then we can choose any option. It doesn't really matter. And then the question really is, what risks are we addressing by this learning story? That can help us figure out the budget. So there's 2 different types of risks that people tend to be addressing with this. And there's a third category that creates problems for using learning stories. So when you look at the developer's job, tech delivery job, the risk we're addressing with learning stories is, will I need to kind of rework shit for 6 months? People hate doing rework. Will I have to delay other stuff in order to kind of do, am I making kind of a wrong decision here? Am I going to cause a lot of tech debt by doing this? If I change my delivery pipeline to tweak those kind of language codes around and it's wrong, then I need to undo that and things like that. Then you have business development that really loves learning stories, because people in business development, they do this all the time. They will launch a product in a smaller market. They will try something with users. They will figure it out. And for them, they love learning stories because they do not have to be right. The risk they're addressing is being right or wrong. The risk they're addressing is being fired for spending 2 years on building the wrong thing. The people who cause a problem in between are the middle management, because the middle management is usually tasked by delivering something on time and budget, and then they care about, what do I need to deliver? And they will tell you this is impossible. You can't do this, and the business people don't want to talk to you, which is a lie, and things like that, because they're protecting their own territory. Now, there's a couple of responses to this, and one response I really love is I saw a TV series on Disney Plus recently, again, too much time on my hands, not enough travel, about industrial light and magic. If you like sci-fi movies, watch that, it's wonderful. You can see how much that's influenced our industry, and not our industry, but kind of the film industry. And they have a couple of scenes there where they talk about George Lucas's method of dealing with this is impossible. Because industrial light and magic was always pushing the envelope on everything. And there was Dennis Muren, who is one of the kind of lead, I think he was working on modeling and models, physical models then, said kind of for the Attack of the Clones, they created this thing that would cause them to have to do like 2,000 shots in a year and a half. It's totally impossible. So when they came up with that, everybody started yelling at George Lucas, saying, no, we can't do this. No, there's no money that can help us do this. It's not enough time. We can't do this. And basically, George Lucas always had the same response. He said, kind of, just go and think about it for a bit, and he left the room. And usually what happens is 10 minutes later, somebody has an idea how this could possibly be done. So sleep on it a bit. Think about it. Get people, if they say this is impossible, try to think about this for a bit. And I have a technique for you to use more practically for this. And the technique is called nijite. And it sounds like a Japanese loan word because, we in tech like to steal Japanese loan words like Kanban and Gemba and shit. But it's not. It's actually kind of an invented acronym. It stands for kind of, it's not impossible, it's just too expensive. There's very, 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 very few things in tech today that are truly impossible. Yes, there are truly impossible things. But very often when people say it's impossible, what they mean is it's going to cost too much money. And then we can manage that. We can figure this thing out. We can figure out how do we reduce the amount of money this is going to cost. And this is where the technique I like to use is first get people to think about, let's find the most expensive variant of doing this, so that we can talk about this is expensive, it's not impossible. So going back to kind of the Google thing, start with the most outrageous thing you can think about. So who's watched Mission Impossible, the first movie? Like Tom Cruise going down, yeah. So one option is, hire fucking Tom Cruise to go and steal the data. Now, he's a bit too old to do this now. Maybe, he's no longer that agile as before. There's certain legal implications here that are not good. Outrageous. Let's not do that, The second outrageous option is, well, I could, I don't know, seduce and blackmail a Google exec, Now, the problem here is, first of all, I wouldn't know how to explain this to my wife. And the second thing is, given my look, the exec would have to be blind, obviously, so not going to work. But then, somebody comes up with a third option. For example, well, we could buy enough Google stock to get a seat on the board. Like, as a Google director, I could just ask them, not even how the algorithm works. I could say, put my website there, peasant, I want to be number one. And, okay, now we know it's not impossible, it's just really, really, really expensive. We've established that. So, can we do things that are less expensive here? And this is where Doug Hubbard's work comes brilliant. That's why you should read the book, How to Measure Anything. And he talks about how basically you have this whole curve of uncertainty and investment. So yes, we could, buy all the Google shares in the world. We would have 100% certainty. Or, we could do something for less money. We wouldn't be that certain. And Doug says that kind of the purpose of measurements is never really to eliminate uncertainty, because that's often too expensive, is to reduce it. So kind of let's try to reduce uncertainty with learning stories, not necessarily completely eliminate it. And then it's no longer impossible. Can we do something that reduces uncertainty to a level we are comfortable with? That's the big question. So kind of rule number 3 is for slicing stories. If they're too big, too expensive, we should really slice by confidence. How much confidence do I need to have that Google behaves this way? Hey, do I need to be certain enough that I can play around with a few pages? Do I need to be certain enough to kind of flip the whole website over? And how can we slice it in that way? So here's a couple of ways how people typically slice stuff by confidence. So we could deploy to a smaller group of people. We could just expose it to 20 users, to 1,000 users, to 10,000 users, whatever smaller means for you. We could run something for a short period of time. Like, let's just run it for one night. Or 1 month or something like that and see what happens. Let's provide it on a different brand. If the big risk is that we're going to ruin our brand, let's set up a totally different application, launch it. Nobody needs to know about this. There was an example of this where the AlphaGo engine that kind of plays Go and chess and things like that from DeepMind, they started playing chess on a chess competition website, but they completely used a different brand, a different name, so that it wouldn't be recognized as them. And that's how they reduced the risk to their brand. We can, offer an alternate version or a pre-release. Get 5 people from the customer to come in and test it on my laptop. There's a million ways we can do this that give us different levels of confidence. And that's why I think slicing by confidence is really important, because then we have more confidence of doing the next step of learning. And this kind of brings the discussion from, we don't have to be right, to how right do we need to be about this? How critical is this? How important is it? How much certainty do I need to have? So about kind of 5 or 6 years ago, we had this really interesting situation with the tool I'm building with a colleague. And there's only 2 of us in the company, so when the 2 of us disagree, there's no real way to resolve this stuff. And I had this brilliant idea that I'm going to create integration with Wikidata. Wikidata is a public knowledge graph. And we're going to let people do research just by clicking a question mark, and this randomly populates kind of data using Wikidata. And I thought this is the best idea in the world. My colleague and business partner said this is the stupidest idea anybody ever thought about. And we couldn't kind of agree or disagree. So I decided, okay, I want to do a learning story about this. And how right do we need to be? And he said, yes, but you can't put anything in the main line. I don't want you to change kind of the main line of the code or anything like that. So I created a totally alternate version we exposed to a few people and try to figure out, if we give it to 1,000 people, will they use it the way they're going to use it? And I was so certain about this that, the learning story is really going to help me win. We launched it in a week, 100 people used it, and then after that, it was just a novelty that wore off. Nobody wanted to use it anymore. So, yeah, I was proven kind of stupidly wrong. And the interesting thing here is lots of people, when they do learning stories and stuff like that, kind of like we did this Wikidata thing, they try to massage the data in their own benefit. If I stopped the research after the first week, I could have said, this is really good. And this is where there was a really interesting thing to consider. How do we know we have the relevant data? How do we know we have enough to conclude something or close something? Have we budgeted this thing enough? And in particular, kind of people tend to massage learning stories, even small wins like, 5 people more clicked on this. It's a good idea. How do we know that? So there's a ton of stuff that you can read about this online, relevance in research and things. There's a wonderful paper I like to recommend, and I'll give you the link, called The Lizard Man's Constant. And it's by Scott Alexander, who writes the Star Slate Codex blog. He talked about how when they were doing some public research, and they created this website that required people to put their nationality in, and to do some research, there was, people giving them really, really confusing answers, like somebody entered male as a nationality and American as a gender. Some other people wrote that they're from Mars because, they want to sabotage this thing. So there's a bunch of people who do crazy things, like invert Unicodes and things like that. And he came up with this constant from some other research they've done where apparently 4% of Americans believe that lizard men are controlling the United Nations. So he called it the lizardman's constant. It's kind of 4%. So if your research is less than 4% conclusive, you're really talking about lizardmen here. It's not, nowhere close to where we need to be. So what I'm trying to say is, don't massage the data to let your theory become a conspiracy. We're not going to, mess up our product by doing that. And we need to keep kind of research relevant. So that's kind of the rule number 4. Keep it relevant and honest, and especially if the data is not going in your favor. Accept that your idea was stupid and move on. And kind of to finish this thing off, some experiments you run will necessarily fail if all your learning stories succeed. You are not doing proper research. You're doing research stuff on stuff you already know. So stuff is going to fail, and we need to figure out what to do with that. And again, I'm a consultant, so I like to talk about quadrants. We have if something succeeded or not, and do we have any clue on why this succeeded or didn't succeed? That's really interesting. So I came back from a trip last week, and I found my internet router flipped kind of on top, upside down. I was like, well, what's going on here? And my son said, oh, the internet works much better this way. How do you know? Well, the game was really slow to download, and I kicked this thing. I was angry. It flipped, and it started downloading faster. So, okay, but people do this kind of stuff in software research all the time. There was a wonderful screenshot I took before Corona while I was still flying like crazy on the KLM website. KLM is the Dutch airline. I was booking a ticket, and they showed me this thing where it said, would you like to give us 50 euros for product name here? I was like, yes, of course. Can I pay with insert credit number here? I don't know. And this is kind of, you can see they were doing some research here. They were doing something that doesn't scale. They released it in probably one language, I assume Dutch. And it wasn't ready for English translation, but they published it anyway. Now, the problem with this is tomorrow morning, some product manager looked at the data and said 99 people didn't want to upgrade. 99% did, because I have no idea what I'm giving you 55 euros for. But do we know why they didn't want to upgrade? Well, who knows? Maybe we've messed up something in software. Maybe we did something else. So we have these kind of really categories of, yes, we have a failed trial. We know why this failed, but then we have, and don't do this, please. And the other thing that kind of then, if we kind of have this stuff up, really, sometimes people declare, oh, moving the button left creates lots of value, and then they deploy that, and then a month later, the website has a big problem because we didn't understand why. So we want to be in this category here, and that's rule number 5 that I really want to leave you with. It's kind of make sure when you have a learning story, not just that you know if it worked or didn't work, but why. Why did it produce this data? And that will help you create more value in the future. So that's kind of everything I had for today. That's 5 rules. Going over this thing again. First of all, don't try to make it perfect, do things that don't scale. That's how we save on cost. And come up with really weird ways of making it not scale, because that's all we're trying to do. The other thing is, don't try to estimate learning stories because it's pointless. Try to budget for it, and budget for it based on the risk, budget for it based on the value. And if the first budget is too much, then slice by confidence. Do something that gives you a bit more confidence, so then you can decide, yes, we want to invest more in research, or no, we don't want to invest more. Then kind of really be honest, and this is the most difficult thing because people like their ideas to succeed. And keep it relevant on the research you want to do. And last thing is make sure you understand why something worked or didn't work. Don't kind of flip the router upside down and think you're improving the internet. The slides are on my website. You can download them immediately. Thank you very much.